Have you ever noticed that whenever you look up at the night sky, the moon always looks the same? The same craters, the same patterns of light and dark, the same face staring down at us night after night. Humans have been gazing at the moon for thousands of years, and no matter where you stand on Earth, the moon never seems to turn. It's as if it is frozen, locked in place, showing us only one side forever. And so a mystery was born. Why do we never see the so-called dark side of the moon? Is it really dark? What does it look like? And what secrets could it hold? The truth behind this mystery is both simple and profound. The moon is what astronomers call tidally locked to the Earth. Long ago, billions of years in the past, the moon spun much faster on its axis. But over time, Earth's gravity began tugging on it, slowing it down little by little. Eventually, the moon's rotation slowed until it matched the time it takes to orbit Earth. Now, the moon rotates once on its axis in the exact same amount of time it takes to circle our planet. The result is that the same hemisphere of the moon always faces Earth. From our point of view, the moon seems not to rotate at all. But in reality, it does. It just rotates in perfect sync with its orbit. This process, called tidal locking, happens because of gravitational interactions. Earth's gravity creates tidal bulges on the moon, and over millions of years, friction inside the moon dissipated energy until its rotation matched its orbit. Once locked, the moon couldn't escape the arrangement. And so we on Earth have always been shown the same face. It's a cosmic dance that feels almost deliberate, but it is simply physics at work. Now, what about the far side, the side we never see from Earth? For centuries, humans could only imagine it. Some thought it was dark, barren, and lifeless, leading to the popular phrase, the dark side of the moon, but that name is misleading. The far side of the moon is not always dark. In fact, it gets just as much sunlight as the side we see. The reason it looks mysterious is simply because we cannot see it directly from Earth. Half the moon is always hidden from us, but it still goes through day and night just like the near side. The first glimpse of the far side came in 1959, when the Soviet spacecraft Luna 3 flew around the moon and sent back grainy images of the hidden hemisphere. What scientists saw was astonishing. The far side looked very different from the familiar face we see in the night sky. The near side of the moon is covered in large dark patches, which are vast plains of ancient lava called maria. But the far side had almost none of these. Instead, it was dominated by craters, mountains, and rugged terrain. It was rougher, older, and more scarred by impacts. Why the difference? Scientists believe it has to do with the thickness of the crust. The near side's crust is thinner, which allowed lava to flow and create maria. The far side's crust is thicker, so lava could not rise to the surface as easily. As a result, the far side looks dramatically different, a world of craters compared to the smoother, darker patches of the near side. This difference has scientific importance. By studying the far side, scientists can learn about the history of the moon and the solar system. Craters are like a cosmic record of impacts, and the far side preserves more of that record. Missions such as NASA's Lunar Reconnaissance Orbiter have mapped the far side in detail, revealing its rugged beauty and geological mysteries. China's Chang'e 4 mission even landed a rover on the far side in 2019, the first in history to do so, opening a new chapter in lunar exploration. The far side is also special for another reason. Because it always faces away from Earth, it is shielded from the constant radio noise produced by human civilization. Our planet is buzzing with signals, radio, television, radar, satellites. All of these create interference that makes some astronomical observations difficult. But on the far side of the moon, it is perfectly quiet. For scientists, this makes it an ideal location for building radio telescopes that could study the universe without interference. Imagine a giant observatory on the far side, listening to the faint signals from the early universe, signals that would otherwise be drowned out by Earth's noise. That possibility has excited astronomers for decades. Of course, building on the far side would be challenging. Communication with Earth is blocked by the Moon itself, so any base or telescope would need relay satellites to stay in contact. But the scientific rewards could be extraordinary. Some scientists believe we could finally detect the faint whispers of the universe's first stars by placing instruments on the far side of the Moon. Beyond science, the far side has always captured the human imagination. For centuries, poets and dreamers wondered what was hidden there. Was it home to mysterious creatures? Was it bathed in eternal shadow? Even in modern culture, the far side of the Moon has inspired music, like the famous Pink Floyd album. The idea of a hidden world just out of sight resonates with our imagination. We know it's there, yet it remains invisible, mysterious, and intriguing. One of the interesting aspects of this story is how humans misinterpreted what they could not see. Because the far side was unknown, it was easy to assume it was dark. But in truth, the far side is no darker than the near side. Both halves of the Moon experience roughly 2 weeks of daylight followed by 2 weeks of night. When it is daytime on the near side, the far side is in night, and vice versa. So while we call it the dark side, it is only dark in the sense that it is hidden from us. The Moon's synchronization with Earth also raises fascinating questions about the history of our planet. The gravitational interaction that locked the Moon has also been slowing Earth's rotation. Our days have been getting slightly longer over millions of years. In the distant future, it is possible that Earth itself could become tidally locked to the Moon. If that happens, one hemisphere of Earth would always face the Moon, and the other would never see it. That would be a truly strange world. The Moon is not the only tidally locked body in the solar system. Many moons of Jupiter and Saturn are tidally locked to their planets as well. It is a common fate for moons and planets that orbit closely over long timescales. But because the Moon is our closest neighbor, its tidal lock feels especially significant to us. It is the reason that every person who has ever lived has seen the same face in the night sky. When the Apollo astronauts orbited the Moon in the 1960s and 70s, they were the first humans to see the far side with their own eyes. They described the view as stark, filled with craters, rugged mountains, and desolate plains. For them, it was a reminder that the Moon is not just a familiar companion but also a world with hidden sides, a place of mystery as well as beauty. Today, with modern satellites and rovers, we know much more about the far side. We know it is heavily cratered, geologically ancient, and scientifically valuable. But it still holds secrets. We still don't fully understand why the crust is thicker there, why the two sides are so different, or what resources might lie hidden beneath the surface. And for future explorers, the far side may be the next frontier, a place where humanity builds bases, telescopes, or even permanent settlements. The story of the Moon's hidden side is also a reminder of perspective. From Earth, it looks as if the Moon never changes. But from space, you would see it rotate as it orbits, revealing all sides. Our view is limited by our position. In a way, the far side of the Moon symbolizes the limits of human perspective. There is always more to see, always more beyond what we can observe directly. So, why do we never see the dark side of the Moon? The answer is tidal locking, the gravitational dance between Earth and Moon that keeps one hemisphere always turned toward us. The far side is not truly dark, only hidden. It receives sunlight just like the near side, it has mountains and craters and mysteries of its own, and it may one day host instruments that reveal the earliest secrets of the universe. What was once a mystery is now partly understood, but still full of wonder. The Moon has been with us since the dawn of humanity. We have sung about it, told stories about it, and sent missions to it. And yet, even now, it continues to hold surprises. The far side reminds us that even in our own cosmic backyard, there are still places we cannot see directly, still questions we cannot fully answer, and still mysteries waiting to be uncovered. So the next time you look up at the moon, remember that there is another side, a hidden world that no human on Earth can ever see with their naked eyes. It is not dark, but it is unknown. And one day, perhaps soon, explorers will walk there, uncovering secrets that have been hidden for billions of years. The moon always shows us one face, but the other is there too, patiently waiting for us to discover it.